In this lecture, we're going to cover several objectives. We're going to start by looking at the different layers that make up a PC, including both the hardware and software layers. It's important to know this layered structure so you can differentiate hardware problems from software problems. We're also going to take a look at the BIOS and drivers that make up a PC. We're going to look at the motherboard ROM BIOS and the different routines that are contained within it, including the BIOS setup, bootloader, and various other routines. We're also going to take a look at the CMOS RAM on a typical motherboard. And then finally, we're going to take a look at the different kinds of ROMs, especially focusing on the newer flash ROM type of ROM chip device, which is found in almost all motherboards built since 1996. The flash ROM is the user upgradable ROM. We're going to take a look at a specific example, see how you can determine the version that's contained in your motherboard and how and where you will get updates. We're going to take a look at the difference between hardware and software in a PC. Now, most of my classes are about PC hardware. And if you're troubleshooting a problem in a PC, you need to be able to figure out whether that problem is being caused by the hardware or the software. I mean, if it's a software problem, you're going to be either reloading the software, perhaps changing things like drivers or configurations of the software, things like that. If it's a hardware problem, obviously you'll be replacing the hardware that's defective. You'll be replacing things like the motherboard, a video card, a disk drive, a cable, things like that. So it's very important whenever you're dealing with a problem in a PC to be able to isolate the problem to either being a software problem or a hardware problem. Now, to get into that, let's take a look at a diagram of a PC broken up into its constituent layers. When I break a PC up into layers, I come up with 4 main layers in the PC. You see them on this diagram. We have the actual hardware, then we have what's called the BIOS and device drivers layer, operating system, and application programs. Now, when most people deal with a PC, work with a PC, they work with the applications. The application program, is what most people think of when they think of a PC. I know people who are great with specific applications, like they know a particular word processor inside and out. Sit them down in front of a PC running that word processor, they're totally at home, they know all the commands and menus. Take that application away and put a different one there, and they might be lost. You can even have the same application running on different PCs. Whether the PC is different underneath, the actual hardware may be different, as long as the application is the same, the menus look the same, the commands are the same, etc. Now, most people think of the application as communicating directly with the hardware, but that's not true. If you look at this layered setup that we have, the application program actually communicates with the operating system, which is the layer in between the application and other layers like the hardware. The application program communicates with the operating system through what's called a standard interface we know as an API. Now, what does API stand for? Well, it stands for Application Program Interface. And I like to think of the API as sort of the hidden command structure or menus, commands, what you will, between an operating system, like let's say Windows, and an application. I could be let's say I'm a programmer and I'm writing a word processing program. What's my program going to need to do? Well, one thing my program is going to need to do is be able to take the data that's been typed in on the screen and save it to a file on the disk. Now, as a programmer, do I need to know how disk drives work? Do I need to know, for example, what electrical impulses to send to an ATA drive to get it to do the job? Or what if it's a SCSI drive, Small Computer Systems Interface drive, instead? Am I going to need to know that? No. In fact, some of the best programmers I know virtually nothing about computer hardware. I was kind of surprised when I first started in the business, many years ago, and I realized that to be a programmer, you don't need to know anything about the computer itself, about the actual hardware. That's because you're insulated from it. All the programmer needs to know is the interface that they're talking to. Like, for example, in Windows, what the programmer needs to know, who's writing a word processing program that's going to run under Windows, is what Windows internal commands do they use to cause Windows to take the data, save it to the disk, and so on. So what happens is the application program here, shown in this bottom layer, sends commands to the operating system, basically invoking the save a file function, and then the operating system converts that to commands for this layer, which we call the BIOS or device drivers layer, which then actually sends the commands to the hardware. So it's kind of like a chain of command where each layer talks to the layer above it or below it, depending upon how you organize the chart. And obviously the hardware is what we're most interested here, this being a course about PC hardware. Anyway, another reason for showing you this diagram is to show you that we can have two totally different sets of hardware. I could have PC A and PC System B, and the two different PCs could use completely different motherboards, different processors, different chipsets. They could use different types of disk drives. One could be ATA, one could be SCSI. They could be radically different in the actual hardware, and yet the same application programs will run on those machines. And that's what this diagram is showing. The same application will fit on both machines. In fact, what's even more strange and surprising to me initially is that the same operating system can run on the two machines. That's because the operating system does not talk to the hardware. The operating system talks through a standard interface to this layer here. Now this layer, the layer right below the hardware in this diagram, is a very important layer. So we're going to spend some time talking about that. Now if I had to give this layer a one-word description, I would call it the BIOS. Now what does BIOS stand for? Well, Basic Input-Output System. Now when people think of a BIOS, a lot of times they'll think of the ROM BIOS. What's a ROM BIOS? ROM is read-only memory basic input-output system. Now that's normally a component, a chip, found on the motherboard of a PC. But that's not all of the BIOS. In fact, in a modern system, you have more BIOS loaded into RAM than you do actually in the ROM chip on the motherboard. Another way to look at BIOS is this. Think of BIOS as all of the drivers for all of the hardware in the machine kind of taken as a lump sum total, whole entity. For example, in your system, somewhere in the system, you have a keyboard driver. And then every time you press a key, that driver is invoked, and it takes the key press and either reads it, from the keyboard, or one aspect of that driver is to turn the lights on the keyboard. When you press, for example, the caps lock or num lock key, that driver is actually responsible for turning those lights on. So that driver can both send commands to the keyboard as well as read data from the keyboard. You have a hard disk driver in the system. You have video drivers. You have drivers for your serial and parallel ports and USB ports and all of the other interfaces on your PC. You take all these drivers together as a total, and we call that the BIOS, the Basic Input-Output System, which is all the really low-level software that talks directly to hardware. You can't have hardware without a driver. If you look at the way I've done this diagram, you can see that the BIOS is kind of like the compatibility glue. It's the adapter or interface between the hardware and the operating system. You notice that the operating system on the left-hand part of this diagram is the same as the one on the right. I'm trying to show that we have the same exact operating system, but yet running on two totally different pieces of hardware. And if the hardware is different, the drivers have to be different. Where do you get a driver for a particular piece of hardware? Like let's say you buy a brand new video card. Where are you going to get the drivers for that video card? Well, from the company who makes the video card. They're the ones responsible for creating the drivers. Now drivers are sort of a two-way street. The driver not only has to talk to the particular hardware, it also has to talk to the operating system that's involved. So for example, if you were going to run the latest Windows XP and you wanted to use a particular video card, you should find out if the company who makes that video card has produced drivers for that card to run under Windows XP. If you want to run it under Windows 2000, also you'll need to see if they have drivers for that, Windows 98, ME, etc. Let's say for some reason you wanted to use OS2 as an operating system. Well, good luck finding a new video card where that company has written drivers to run that card under OS2. So the driver has to work not only with the hardware, but also with the operating system, and you have to make sure that your driver matches both. So if you change operating systems or you change hardware, you very likely will have to change the driver that's involved. And in almost all cases, these drivers will have to come from the company who makes the hardware. Now, a lot of times when you install some of the newer operating systems like Windows XP and you pop the disk in, it'll scan all of the hardware in your system and then automatically install drivers for it. How did that work? Did Microsoft write those drivers? No, they did not. But what they did do is collect the drivers from all of the hardware companies for their most popular products and build those drivers into the Windows disk so that would make the installation easier. It was in their best interest and yours to have as many drivers as they could on that Windows CD so that when you do go to install it, you don't have to find all of these extra disks having the drivers for the various cards and other things that you have. So this layer, BIOS, is the drivers that interface the hardware to the operating system or the software in the machine. Now we're going to take a look at this BIOS layer in more detail. If we're going to take this layer, the BIOS, and break it up into its constituent components, we'd have, well, several. Let's look at it as the initial ROM BIOS and then also the other device drivers that you load on top of it. Let's move over here and take a look at this motherboard and see if we can find the ROM BIOS on the motherboard. If I take a look here, I can see a lot of the major components. For example, here's the processor with the heatsink attached, mounted in the processor socket. We've got slots and places to connect memory and disk drives and other things. Now the ROM BIOS on this board happens to be right here. Let's take a zoom in on it right here. And you can see the chip, and it has a sticker on it from AMI. Now this is an older motherboard. It's not important how old or current it is. I just wanted to show you a typical BIOS chip. Now this one's from AMI, American Megatrends International. They're one of the three big BIOS manufacturers. There's Phoenix, AMI, and Award. And Award was recently bought by Phoenix, so they're really the same company, although they do still market the products separately. Now, AMI, American Megatrends International, has installed their code into this chip. Now we can look at a ROM chip from really a couple of different perspectives. We can look at the chip by what it contains, or by actually how the chip itself works. Now we're going to do that both ways. First, let's look at the BIOS by what it contains, and then we'll look at how the actual chip works. What is in this chip? Well, you could think of this chip very much the same as you think of a floppy disk. It's a storage medium. In other words, we store data in this chip. Now there's a difference between a ROM chip and a normal type of memory chip. I have an example here. This is a SIM, or single inline memory module, with standard RAM chips on it. What's the difference between these RAM chips and this ROM chip? Now, of course, obviously, RAM stands for random access memory. But what's interesting is that ROM is also randomly accessible. So actually, the term RAM and ROM kind of being thought of as opposites is really not technically correct. All ROM is also RAM. It's randomly addressable. But normally when we say RAM, we don't mean the ROM. We mean this specific type of memory here. What would be the main difference between these two types of chips? Well, one is read-only, the other one is not. That's true, but that to me is not the main difference. The main difference can be expressed in one word: volatility. RAM is volatile. ROM is non-volatile. Now what does it mean when something is volatile or non-volatile? Well, when you cut the power to the board, volatile memory loses the data. Non-volatile memory will retain that information. This ROM chip, in other words, has data stored in it, which even though it was originally programmed back in 1993, the data is still there, and this board hasn't been powered up for almost 10 years. The RAM here will maintain data for only about 15 milliseconds after the power is removed. Any longer than 15 milliseconds and all that data is gone. So volatility is really the key difference between RAM and ROM. Now some people have, when I've pointed this out, they'll look over to this component here, which is the battery, and they'll say, well, right, the ROM is able to maintain data without power because it has an auxiliary power source, this battery. Well, it is true that almost all PC motherboards do contain a battery, but it is not for the motherboard ROM. There is, in fact, absolutely no connection between this ROM chip and this battery on this board. No, I could remove this ROM chip from the board and it will still retain data indefinitely. I mean, millions of years, or as long as that chip would survive, the data will be maintained. It is truly non-volatile. No, that battery is there for something else, which we will go into in just a little bit. So, we now know the difference between what we call a ROM chip and a RAM chip. Now let's take a look at more what's in this ROM. Well, basically there are four things contained in a motherboard ROM. Let's start with the first thing. What happens when you turn a PC on? What's the first thing it does? Well, it does something we call the POST, which stands for Power On Self-Test. What is the POST? It's a series of tests that test components on the motherboard, test the memory, test the disk drives, and all of the major operating components in the PC before it will boot up. Now, in fact, these post diagnostics, power on self-test internal diagnostics, have been very useful in troubleshooting problems. In fact, I recently had a system which would lock up, seconds after you turned it on. But we watched as the post tests were being listed on the screen, and it stopped right after a particular line was displayed. Well, what we did was we went to another system which was identical and saw what would be the next line that would be displayed, and it was testing the level 2 cache in the system. So by virtue of that, we were able to determine that the L2 cache was what had failed. In other words, when it had tried to test it, it locked the system up. And by replacing that cache, we now restored the system to operation. So it was nice that this sort of built-in diagnostics really did all the work for us as far as helping us figure out what was wrong. So what happens after the post? Well, normally after the post, the system will beep, and then the floppy drive or the CD-ROM drive or the hard drive will light up. What's going on at that point is a process we call the bootstrap loader. That's the second set of routines in the motherboard ROM chip. The bootstrap loader's job is to locate a boot sector, load it in, and execute it. Now, some people say the bootstrap loader is supposed to load the operating system. Well, not exactly. All the bootstrap loader routine does is load a single sector off of a bootable drive, and then that sector loads another boot sector, which then loads the core or kernel files from the operating system. Sometimes they're also called system files. So it's really kind of a chain of events of things that get loaded as a system boots up. But certainly the bootstrap loader here starts that process off by loading this boot sector. Normally what it would be is what we call the master boot sector on the hard disk. So the routines in here locate that master boot sector, load it into memory, into RAM, and then run the program that's contained within it. Then, what happens after your operating system is loaded? Well, after your operating system is loaded, there are drivers inside this motherboard ROM which can handle various components in the system. For example, in that motherboard ROM, there's a keyboard driver. There is a basic hard disk driver. There's a floppy disk driver. There's a serial port driver, a parallel port driver. Now, these drivers are only used with 16-bit operating systems because the code in these drivers is actually 16-bit code. What that means is that if you're running Windows NT, Windows 2000, or Windows XP, see, those are completely 32-bit operating systems. They use no 16-bit code, no 16-bit drivers. So in effect, while at a screen with while at an XP desktop screen, none of these drivers are in effect. In most modern systems, in other words, the motherboard ROM functions only during the boot process. As the system is booting, loading Windows XP, for example, alternate keyboard drivers, hard disk drivers, and other drivers are loaded into RAM and then executed. In fact, in a modern running PC, you have virtually no drivers in ROM. All of the drivers in your system are in RAM. What happens when you turn the power off? Well, of course, all the drivers in RAM vanish. What happens when you turn it on the next time? The same boot process occurs. So the drivers must be stored somewhere other than in the motherboard ROM and in the RAM. Well, where they're stored is on the hard disk. So we have drivers stored on the hard disk, which are loaded during the boot process into RAM, where they execute. For a driver to run, it must be in memory. It must be either in ROM or RAM in order to be executable. So if we have a driver on a hard disk, and we say that driver is installed, to me that means something. A driver that's installed means that the driver is not just sitting on the hard disk, but it is configured, or the operating system is configured, so that every time the system boots up, that driver is loaded from the hard disk into RAM. And it happens automatically. That's part of the boot process. The more different hardware components you have in your system, the more drivers are going to be loaded. Your boot time is going to be a little bit longer because of that, more drivers being loaded. In fact, let's look at this another way. Where can drivers reside in your system? There are right now only 3 places that drivers can run in your system. And we see 2 of them right here. Drivers can be in the motherboard ROM. Most of your drivers are loaded into RAM, Of course, all the drivers that are loaded into RAM also reside on the hard disk, but they're not executable from the hard disk. So I don't say that the drivers are on the hard disk because they can't run from the hard disk. They have to be loaded from the hard drive into RAM. What's the third location where you'll find drivers? Well, the third location will be adapter cards. For example, here I have a video card. Now, when you turn a PC on, do you see video on the screen immediately? Well, usually a few seconds after you turn it on, yes, you do. How did that work? How did the drivers built into your motherboard ROM know how to operate this particular video card? What if you bought a different brand? Do they have hundreds of different drivers in there for hundreds of different brands of video cards that are on the market? Because they are all different, and they all do need different drivers. Well, no, would be impossible. There isn't enough space to fit drivers for the hundreds or thousands of different video cards that are on the market. So back in 1981-82, when IBM was first designing the PC, when it first came out, they built in a routine into the motherboard ROM which would scan all of the bus slots, all of the slots where you have cards plugged in, looking for ROMs on the card. This video card has a ROM chip on it right here. And this ROM chip contains the initial drivers for this video card. And those drivers are what allow you to see the power on self-test and the actual boot process taking place. Now, I had somebody ask me once, well, if the drivers are in this ROM chip that's built into the video card, then why did I have to install additional drivers in Windows? Well, there's a limitation. The ROM chip that's built into a card like this, at least especially video cards, is limited to 32K kilobytes, kbytes in size. And there's just simply no way they could fit all of the drivers necessary to run this video card in a 32K space. So all we have here in the ROM are drivers to support text mode and the most basic VGA graphics mode. Now, if you've ever run Windows in what's called safe mode and you've looked at how crude the screen looks, there's a very low resolution, usually 640 by 480 pixels over and across, and also only 16 colors, that's because that's all that built-in ROM driver supports. You'll notice that when Windows starts up, you usually start off with a low-resolution Windows logo screen, and then it clears, and then a high-resolution desktop appears. Well, that is exactly the point when your video drivers were loaded from the hard disk into RAM to really operate the video card to its full potential. So, again, 3 sources for drivers in your system, or 3 places where drivers reside in a running PC. Number 1, in the motherboard ROM. Number 2, in RAM, such as a SIM or DIMM memory module. And number 3, they can be in ROM chips on cards. Now, what kind of cards would have ROM-based drivers on them? All video cards do. That's pretty much a given. Other types of cards, SCSI adapters. That stands for Small Computer Systems Interface. Those are adapters used to run SCSI hard drives, CD-ROM drives, etc. Your motherboard ROM does not know how to boot from a SCSI hard disk. So in order for that to take place, you plug in a SCSI adapter, and it has a ROM on it with the initial drivers to recognize that hard drive and allow booting from it. Another card that might have a ROM on it is a network card. It's also possible to have a boot ROM on a network card. For example, I've seen PCs on a network where the PC has no hard disk, no floppy disk, no CD-ROM drive, in fact, no drives of any kind. Yet you turn the PC on, it seems to load the operating system, and you can then load applications. How does that work? Well, the operating system in that case is being loaded off of a file server. Now, the thing is, no motherboard ROM I'm aware of knows how to do that for every different type of network card and different file server that's out there. That's why it's the responsibility of the card manufacturer to provide that as an option on the card. So almost all of your modern network cards either have the ROM built in or have it as an option. And we call that network boot ROM. Sometimes it's called an IPL for initial program load ROM. So I've just named at least 3 different types of cards that have ROMs on them. Video cards all do. SCSI adapters, the better ones do, that allow support for bootable hard disks. And network cards, they typically do as an option, but most people don't really use that option. Most people still boot from their normal hard disk and then log onto the file server and don't load the operating system off of the file server. So the boot ROM may be present on your network card, but you're probably not taking advantage of it. All right, so we've covered the places for drivers to reside in your PC. We've talked about the difference between ROM and RAM. and we've talked about the different components that are in the motherboard ROM. You know, I left one thing out. In the motherboard ROM, there are 4 things, and we've only covered 3 of them. What is the missing piece? Well, some of you are probably thinking about it already. It's the BIOS setup program. That's the program that you use to configure the initial, the settings in your PC, things like the hard drive settings, other basic motherboard configuration items, even things like the speed of the processor and buses in the system are all configured in this BIOS setup. Now, the reason I skipped over it was actually intentional. When you normally turn a system on, you don't go into the BIOS setup every time you turn it on. You go from the post to the bootstrap loader, and then if necessary, any of the drivers in there will be running in the background while you're running your operating system. During the post, almost all systems allow you to hit a keystroke combination, either one key or a combination of keys, to jump into this BIOS setup. Now let's take a look at that in a typical system.